This is Dr. John Bergduff. In this video, we're going to take a close look at the metric system to get a general idea of how it works and also to see how easy it is to convert from one metric unit to another. So the metric system is currently used as the standard system of measurement in all of the countries in the world except for the United States and a couple other really small ones scattered here and there. The metric system dates originally to 1791 when France adopted the units of measure, the mètre, the litre, and the gramme, which we now know as meter, liter, and gram. In 1875, the Convention du Mètre established a process for standardizing the metric system based on artifacts. In other words, they created a bar, a metal bar that was understood to be, this is a 1 meter. And those bars were copied and sent all over the world to be the standard for this is a meter, and other artifacts for liters and grams as well. The problem with that is that metal will expand and contract, and so it's not the most absolute precise measurement of a length. So in 1960, some international conventions created the Système International d'Unités, or SI system, in which the units of measurement for meters are based on wavelengths of light, something that is far more universal and unmutable than the length of a bar. And the most recent clarification of the metric system was as recent as 2019. And now all the measurements in the metric system are based completely on constants, immutable, unchangeable constants in nature, rather than relying on artifacts like a standard meter bar or a standard liter volume. The metric system is based on what are called base units. Rather than having many different units for length, like we do in the English system, where we have feet and we have yards and we have furlongs and miles and so on and so forth, in the metric system there is one unit, and that unit is the meter. The symbol for meter is M, and a meter, to kind of connect it in with what we're comfortable with in the United States, is about 39.37 inches. Or to make something to just help us see it more visually, a meter is just slightly longer than a yard. The unit of volume is a liter, and the symbol for liter is an L. 1 liter is 0.264 gallons, so a liter is approximately 1 quart. And actually, that is one unit that we do see in the United States pretty often. We put our Coke in liter bottles. Finally, the gram. The gram is a unit of mass, and the symbol for that is G. Now, a gram is actually a very small unit of mass. 1 gram is about the same as 0.035 ounces. So for many purposes, we talk instead about the kilogram, which we will explain what that is in a minute. But a kilogram is about 2.2 pounds. So if you hang on to the idea that a meter is about a yard, a liter is about a quart, and a kilogram is about 2.2 pounds, you're well on your way to understanding the metric system. Now, there are other base units for things like temperature and many other scientific constants, but these are the ones most commonly encountered in day-to-day life. Now, rather than creating, like I said, many different units for weight, smaller and larger, it is still important to have some sense of a unit that is good for a very small weight and a unit that's very good for a very large weight. In the metric system, that is handled by simply putting prefixes in front of the basic units of gram, liter, or meter. And the prefixes all represent powers of 10. The prefix kilo represents 1,000. So, for example, 1 kilogram is 1,000 grams. But the nice thing about this particular and all of these prefixes is they can be used interchangeably for all the different units, whether you're talking about what mass or whether you're talking about volume or whether you're talking about distance. So it is also the case that 1 kilometer is 1,000 meters. You just put the standard prefixes in front of whichever one of the base units you need. Hecto represents 100, so 1 hectoliter, and see I'm using a different base unit there. 1 hectoliter is 100 liters. Deca, which is abbreviated by DA, stands for 10. 1 decagram is how you read that, is 10 grams. If you're talking about the base unit, you don't put any prefix at all, so gram, liter, or meter. Deci is beginning to look at fractions, so smaller values. A deci is 1/10, so 1 deciliter is 1/10 of a liter. And actually what might be an easier way for many purposes to relate to this is rather than thinking about a deciliter being 1/10 of a liter, think of 10 deciliters as 1 liter. And that's just eliminating the fraction to make something a little bit easier to work with. We will explore that in greater detail later. Centi stands for 1/100th. 1 centimeter is 1/100th of a meter, or perhaps better, 100 centimeters is 1 meter. Milli is 1/1000th, so 1,000 milliliters is 1 liter. And finally, micro, which is 1/1,000,000th. So it takes 1,000,000 micrograms to make 1 gram. Now, all of these units are important in various areas of science. In day-to-day life, what we ordinarily encounter just going about our business, there are really only 3 of these that are that you see frequently, that are largely and more frequently used. And that's kilo, deci, not deci, sorry, got a little carried away there, kilo, centi, and milli. Those 3. Let me show you how those prefixes, by putting them in front of the base units, allows you to understand smaller or larger quantities and how you can convert from one metric quantity to another. So for example, suppose someone says that they have 500 centimeters and they would like you to express that in meters. Well, not too unlike some other unit conversions that we have talked about before, what you do is you need sort of a table of metric units. In this case, all you need are the prefixes. And then you need to establish sort of a chain of units from the unit you're given to the unit that you want. Now, in this case, that's pretty easy because centimeters are given directly in terms of meters in one formula. So it's a very short chain. We can go directly from centimeters to meters using the fact that, and again, I was thinking we might be happier with this expression that does not use fractions. 100 centimeters equals 1 meter. Now to do the conversion, and this is borrowing on a method I've shown in another video, start with the unit that you are asked to start with. Looking at your chain of units, create fractions that are equal to 1, in which the unit that you're trying to get rid of will be in the denominator so that it'll divide out, and the numerator you're trying to bring in is in the numerator so that it will take its place. And we can actually state that a little bit more generally in a more advanced video. So we do know that in mathematics, if you put any quantity over itself as a fraction, that fraction is equal to 1. If these two quantities are equal, therefore, putting one over the other would be equal to 1. So both 100 centimeters over 1 meter is equal to 1, and 1 meter over 100 centimeters is equal to 1. Multiplying any quantity by 1 does not change its value. So if I multiply 500 centimeters by one of the two fractions I just showed you, you're not changing the value. And if I choose it in such a way that old units divide out and new units take their place, then that is how we go down the chain, so to speak, from one unit to another. Multiplying by 1 meter over 100 centimeters is equal to multiplying by a fraction equal to 1, but look at what happens. When I think of the 500 centimeters as over 1, the units of centimeters divide out. There's a mathematical calculation that is far easier than anything you would ever see in the English system. Simply divide 500 by 100, that goes 5 times, and the unit of meters is what remains. So it turns out that 500 centimeters is 5 meters. Now, there are about as many different ways to explain how to do unit conversion in the metric system as there are math teachers, I think. So you may have seen this done a different way. You may explore a way that you like better, and that is perfectly fine. This is just a way to do it, a way that takes us back to the idea of following a chain of units and watching old units divide out and new units take their place. This process I'm showing you is sometimes referred to as dimensional analysis. If you want a fancy name for it. Let's do a couple more examples. And I want to do a couple here where we don't have a direct conversion from the unit that we're given to the unit that we want. And so building the chain is more important. Again, people approach this in different ways, but what I am going to notice, a way to do this, is to realize that, for example, this very first expression gives you a connection between kilograms and grams. So I can relate kilograms to grams, but then I can use this one, remember the base units are interchangeable, to follow a chain a little bit farther and go from grams to milligrams. And writing the conversion facts on these arrows will help me see what kinds of fractions I would need to multiply by in order to make old units divide out and new units take their place. So we know, for example, and we see this right there up above, that 1 kilogram is 1,000 grams. And this line, I'll reemphasize it here, is telling me that remember, you can change out the base unit, that 1 gram is 1,000 milligrams. Now let's build our chain of fractions based on this chain of units. So we're starting with 8 kilograms. This conversion fact will generate two fractions for me, either 1 kilogram over 1,000 grams or 1,000 grams over 1 kilogram. You want the one that would cause the old units to divide out and the new units to take their place. If I put 1,000 grams over 1 kilogram, that's multiplying by 1, perfectly legal, but as you can see, kilograms here divides kilograms there, and essentially takes you on the first leg of your journey, the first link in that chain. You've gone from kilograms to grams. Similarly, then, you multiply by one more fraction, and our current units are now grams. We want to go to milligrams, so I want to take this expression here and create from it a fraction where the old unit of grams will divide out and the new units of milligrams will take their place. So you might see that that is achieved by putting 1,000 milligrams over 1 gram so that the units of grams divide out and our final answer is in milligrams. The calculation is easy. You might remember that multiplying by powers of 10 just moves your decimal place to the right. So multiplying by 1,000, which would move you 3 places to the right, and then another 1,000, which would move you 3 more places to the right, basically says take the decimal point, which is currently right after the 8, and move it 6 places to the right. No need for a calculator or anything fancy at all. Moving the decimal 6 places to the right, 1, 2, 3, 4, 5, 6, puts you right here. And that tells you that you have 8 million milligrams. 8 kilograms is 8 million milligrams. Let's do one more, and actually what I'm going to do is pause my speaking, because if you would like to, you could pause the video and see if you could do this one yourself. Convert 75 kiloliters to centiliters. Okay, if you did that, I am now back, and we are going to look at a chain of units that would get me from kiloliters to centiliters. I have my prefix kilo that tells me that I can go from kiloliters to liters. And then I have my prefix centi, which tells me that I can go from liters to centiliters. And the conversion facts would be that 1 kiloliter is 1,000 liters. Remember, you simply just change out the base unit and use the prefixes over and over. If you're a little worried that those L's, when we write them in handwriting, look too much like ones, you could also do this. You could, instead of writing the L's in standard form, write them in cursive, so kiloliters and liters. Using the same convention and using the second row, which talks about centi, again, replacing meters with liters, we can change out those base units. We would have that 100 centiliters equals 1 liter. Now from that, we can build our fractions, beginning with the unit we're starting with, which the unit we're given, which is 75 kiloliters. I can multiply that by a fraction equal to 1, so that the old units, the units I no longer want, will divide out, and the newer units will take their place, at least the units that will get me through the first chain, the first step of my chain. If I put the kiloliters in the denominator, then kiloliters would divide out, liters would take their place. And we can see that really plainly like this. And then going down to the second link in our chain, we would need to multiply by 100 centiliters, 100 centiliters divided by 1 liter, so that the units of liters divide out and get us to centiliters. And that would complete our chain from here to here, and then here to here. And that will give me my answer, because I simply just need to multiply by 1,000 and 100. That would move my decimal place 1, 2, 3, 4, 5 places to the right. And that would give me 75, followed by 5 zeros. 1, 2, 3, 4, 5. Let's put in commas to make this more legible. 7,500,000. And what unit am I left with? I am now in centiliters. Now, this will feel awkward at first. It will become easier as time goes on. And if you use this a great deal, you'll actually get to where you can say, oh, it's going to go 3 places, the decimal will go 3 places to the right and 2 more, and you'll just do it just super, super fast. And that happens for students in other countries that learn this system from a very early age. The United States is behind on this. It is the only major country that still uses the English system. Interestingly enough, there was a movement back in the 1970s and some tentative laws passed that if we'd stuck with it, would have converted the United States to the metric system back at that time. It was so disfavored by people who didn't want to learn something new that it eventually faded away. But I remember being in math classes in high school and seeing motivational posters, because I was in high school at that time, to encourage people to think in terms of metric instead of English. And just for your amusement, I'm going to show you one that I found online still. Think metric. And if you look very, very carefully down here in the numbers, they may be a little bit hard to see. They have written in the measurements for the grown woman and the measurements for the little girl to help you see how to think metric.